Right, so I'm first up. Thanks for all coming along today. I'll just explain who I am first of all. So Mark Jolly, resin sales, and then I look after the UK and Ireland for resin sales. Welcome to everyone in the room and everyone online as well. Good morning. From Minova here, we've got Nick Hurst as well, who's our technical resin trainer. So he trains up new customers and existing customers with on-site support. So he's available today during the presentation and afterwards if we want to discuss anything in more detail. And then we've got Jamie here as well, who's our marketing guy and helps me set up the laptop and everything because I wouldn't know how to do it otherwise. So that's us. At any time during the presentation, please feel free to ask any questions. Right, okay, so Minova, has anyone heard of Minova by any chance? Right, okay, one, that's good. So we're a manufacturer. So we're actually a manufacturer of ground support systems. We manufacture resins. We also manufacture geotechnical solutions as well, such as soil nails, and I'll come on to other slides later on to show you these products. The main area that I work in is actually the resin production. Me and Nick work in resin production, resin sales. So we don't actually do our own work. So we are a manufacturer. So people like Mainmark and iLine are actually our customers, and sometimes use our products on some of their projects. Not always, but sometimes. So we work closely together. Minova's been around for a long time now, 140 years, and we are hopefully well respected within the industry with our products and also our technical support and also on-site support as well. So what we do is have we got any contractors actually in here today? Right, okay, that's great. So what we do with contractors is if they're new contractors who've never used resin before, then we will train up the contractors. If they're existing companies that are already working with us, then we help them. Sometimes we help them to design projects, or we use our technical teams. We have a technical team actually in the Czech Republic, but work very closely with the UK. And between us, we actually help the contractors win contracts and work together. So we've got we manufacture worldwide, and as it says there, we're actually in 25 countries with manufacturing in 5 countries, as it says there, a range of systems, injection chemicals, grouts, resin capsules, and sprayable membranes. You've probably heard of some of these products. As we go on further on, we have got a few videos which actually show these in detail. So I've just explained we're worldwide, but that gives you an idea of where we are throughout the world. Minova's originally Minova was working heavily in the mining industry. We still are in countries like Australia, Poland, Czech Republic, northern Spain, and we were in the UK market, but obviously with the mining virtually gone now in the UK, we've moved everything over more into infrastructure now, so we work with the infrastructure contractors. So it's repeating the figures there again, but there's an idea of some of our numbers. And so we've got 16 factories worldwide making resin. For the UK market and for the European market, we actually produce our resin in Poland in a place called Katowice, and we take customers out there to actually see production. We went out there recently with Mainmark, and they came and looked at our facilities because we do like people to get involved in what we do. And sometimes, I mean, we've got the R&D as well, R&D teams. So if a customer's looking for a particular product, we will actually help them develop a new resin, which is what we've done in the past with people. And we give people the option, if someone wants to, I don't know again if this is for anyone here, but if someone buys a lot of resin but they like to sell it under their own name, then there is always that option as well, where we can actually what we call white label it, and it will become your product, but we manufacture it. So just a few pictures of the plant there. Minova Ecochem in Katowice. To be honest, there's not, when you go there, you won't see many people. There's a lot of it is all done by machinery and all timed to actually be produced on time. So you won't see many people in the pictures, but what you will see is a very clean working environment. It's very clean, very the health and safety there, and the accident rate. We know that is one of the main priorities for us as a company, on site, but also in the plants as well. So we're producing IBCs, which are the nice large ones, which we're bringing these across to the UK. When we're producing IBCs for people for large sites, we can either deliver that to Barnsley, which I'll show you in a minute, which is our base for the UK, or we can deliver direct to site, depending on how big the project is. We also have a lot. You can't really see here, but we do 20 kilos. 20 kilos. Yeah, 20 kilogram drums as well for smaller projects such as water stopping, which I'll come on into in a minute. This might be for something more like void filling or slab lifting, where you need more resin, so you're going to get larger products. Sorry, larger containers. Yeah, just another picture of the production plant there. I'm not too sure where everyone. Are we all based in the southwest? West, are we? Yeah, and south, maybe Wales as well. But so Minova is for the UK is based in Barnsley, where Jamie's from, and Nick's from that kind of area. I'm actually right down in Portsmouth, so I don't very often go to Barnsley, to be honest. But my job is to promote the sales. I do maybe go there 5-6 times a year, but I don't need to, because a lot of my work is all over the country anyway. So, but we've got a brand new facility here, in really good facility, just off the M1. What junction?
36.
36. Yeah. So you've got a very easy for any customers who want to visit site, or any customers that want to collect product, because you can collect it yourself, and also for our deliveries as well. It's good access, as well as. There's no actual resin in that picture, but we, as well as keeping the resin in the warehouse, we also keep all the geotechnical products such as soil nails, micropiles. Again, we'll come on to that in just a few minutes. Okay, this is really just a little history of how long we've been making things. So. Resin cartridges, which we use for rock bolting, we've been making those since about 1965. These are used to actually, has anyone used these at all? You've used those, great, okay. So you know how they operate. They're used often to put in either bolts in mining, or maybe soil nails on the embankments for maybe motorways or rail embankments. And then 1971, we've been heavily involved in injection resins in Poland, and then quite recently, 2003, we've got more involved in the silicate resins as well. So there's a slide in a minute which explains what the different resins do and what they can be used for. This slide is very similar to this product, this banner here. So this is showing you, as a company, we get involved in all aspects, or most aspects, of infrastructure. Right from a lot of my work, to be honest, is at this level, on the top level. But we've got divisions that work in tunnelling, work in mining still, and quarries in the UK. We get these, can't really see this picture here, but you know, we get involved with resin injection on roads. And then we do a bit of rail tunnel work as well. This is the soil nails.
When you say roads, is that with paving?
Yeah, with concrete roads, the concrete slabs. I've got a case study which I'll show you in a minute. But yes, the resin can be used to actually stabilise the concrete slabs on motorways. You can also work on flexible tarmac roads as well. It's done differently and then you have to resurface. Generally, you have to resurface afterwards. But yeah, I've got some case studies so we can show you details on that afterwards. So the range of resins are we manufacture silicates, polyurethane injection resins, gels, cements and phenolics, and also the product we call Lockset. And on the next slide, if you went onto our website, which would be nice if any of you get a chance to do this, but you'll see there's the whole range of resins on there, probably well over 100 different resins on there. But we try and keep in the UK market down to about 20 or so. So we, you know, there's not too many out there, and some are very, very similar. So we keep to about 20. These are some of the resins. So to give you an idea, something like Carbo we would use for ground consolidation. So if you were using it for maybe for ground stabilisation on a property, maybe using it as an alternative to underpinning on a property. Carboport and 102, 42.
Carboport 42.
42 as well, yeah. So we've got a few products which we can use for ground stabilisation. We've got 42, which is again, it can be used in the ground. Can also be used for, a lot of our resin is used for water stopping as well. Yeah, that's right. So that one's actually a water stopping resin. So a lot of our products are used by contractors in the basement market, you know, who get involved with basements or problems where there's leaks in sheet piling and things like this. So we actually inject. I've got a few slides in a minute which will show you how that's done, but we actually inject and actually stop the water flow, because this particular product actually, as soon as it hits water, will actually start expanding up. And you've got geofoam, which is a product. These are very small containers. I mean, they're only 30 kilos or something, but they're normally sold in IBCs, because geofoam is sold for huge void filling, you know, massive projects where you need to close off a void. No strength, there is some strength, but not much strength in there. It's more for completely shutting off maybe a culvert or a large tunnel or some mines, which I've got details in a minute. CT2 is just the cement we use, which we produce and bring across. And then we've got Carbocryl. Lots of names, you're not going to remember these names, but they're all different aspects. So this one is used for, after we've actually done our repair in concrete, we actually use the Carbocryl to actually close up the crack afterwards and finalise the work. Nick, do you want to add anything about any of those at all, or not, or any others? You know, no.
What is the CT2 cement?
CT2. Do you want to just go?
It's waterproof cement. It's a waterproof one. It's got 2 mil aggregate, and there is a CT6 with a 6 mil aggregate in it.
That's sprayed, right?
You can spray. You can spray the two. Spray the two.
And we sometimes use that on the.
Rapid surface as well.
It's not rapid. A couple of hours of it.
So after the presentation, we've got all the TDSs and data sheets on these, so we can discuss any of these for you. I see what you mean, Jamie. I'll keep pressing it. Okay, so obviously I'm repeating myself a little bit, but these are the areas where we work in, everything from slope stabilisation, retaining walls, rock fall protection, resin injection, sprayed membranes, and then we've got the soil nails and micropoles, which is on the geotechnical side of the company. Just a little, a few shots of things that we would always be interested in getting involved in. Some of these are probably a bit too extreme. I don't know, this is a bit too extreme maybe, but you know, certainly things like sinkholes and that we can get involved in these, and we've got products that we can work with the contractor to actually fill the sinkholes. And then for ground stabilisation, people like Mainmark will speak to you about this later on, but when you've got cracks in walls, then you can do an injection pattern around the outside of the property, inject to a certain depth depending on what the ground reports are, and the idea is to actually close the crack up, lift up, and you're offering guarantee, don't you, normally, David, on your ones? Yeah. So David will talk about that in more detail as a contractor in a minute. This is a sprayable membrane that we use to stop. It's used really to stop rock. We use it on to stop rockfall really, and anything loose being completely sealed in there. We're using quite a lot on a mine in Whitby. What's that new?
Potash.
Potash mine. We're using quite a lot of this there at the moment. Am I just pressing this? Sorry, Jamie. Oh, sorry. Yeah, so potash mine. I don't know if you've heard of that. That's the one which is going from Whitby right across to up to Teesside, which is where this is being used there at the moment, and was specified by the mining teams there because it's used a lot by Minova in America, and so we're quite pleased to get that into the scheme. As you can see, it's a nice fast process. You can cover large areas in a short space of time. By this slide, now this product here, it's a resin being this is done under test conditions, but we'll give you an idea what happens when you do the same work, maybe on a concrete slab on a road or or even in a warehouse. If there's water contained underneath the ground, because the resin doesn't actually, this particular resin, I mentioned one earlier that actually reacts with the water and foams up. This one doesn't react at all with the water. So this will, as it's pumped in, oh, sorry everybody. So as you can see, the resin's being pumped in, and what it's doing, it will start migrating into the actual. Yeah, migrating in, here we go, migrating in, and it's actually pushing the water out. So if this was on, for example, a motorway under a concrete slab, we'd have very small holes drilled into the ground. The resin would go in, the water would come out of the spare holes, so we'd know that water had been all pushed out, and then the remaining resin would then set underneath the actual road, knowing that it was water free. So you then get a steady, stable slab. This one is, there's only 3 videos, so this is the last of the actual videos, but it's quite hard to see this one. But this is not a project I was involved with, but this is a underground, I think it's a tunnel, but it's in Iceland, and it's where they had huge water problems with water coming in, and then our product was pumped and pumped. A lot of resin would have been pumped in, but you'll see that eventually they will stop the actual water flow by injecting the resin in. You actually inject right far back, don't you, Nick? Is that right? Yeah. So you inject back as far as you can get, so the resin keeps coming forward and will get washed out, but eventually it will start setting. Yeah. Okay, so it looks like someone's just turned that off, but that is the process of constantly pumping the resin there and reacting with the water. It could be a long process. Yeah, it can be a lot. Any idea how long that would be, Nick? Or
that one is a couple of hours. That one.
Couple of hours, right? Okay. Yeah. Okay.
Pumping in the same place.
Right. Okay. This was a big project, but this can be used quite easily in where you've got, as I said earlier, basement problems, sheep hole problems, lift shafts, things like that, where you've got water problems. So one of the main projects that we've got done recently was the M180, which was a concrete road that was. Does anyone know the M180 road? It's one of the main roads between Hull and
Scunthorpe.
That's it, Hull and Scunthorpe. Sorry, I'm using Nick here for some of the answers there, but that's it. Yeah, exactly. This is one of the longest stretches of concrete road that's actually. I mean, lots of roads have been injected with resin over the years, but this is one of the longest stretches, and this was directly for national highways. And the beauty of using resin within the road maintenance. It's what they call life extension work. So this road hadn't had any repairs or any major works done on it for about 30 years. So there was two options, either to take up the slabs and replace them, or to come up with an alternative method. So here resin was injected. You can see the kind of drill pattern here. Resin was injected.
Is that to fill the cracks in the?
No, it's not actually. No, it's actually it's a bit like the previous slide. So what you're doing is you're injecting in, you're pushing out any water that's underneath the slabs. There was heavily water on all these slabs, and they were rocking. So as these trucks were going past, they were literally rocking. So the resin would have pushed out the water, and it kept going along for about a metre, and then it would start setting, and then you'd end up with a solid. It's actually 50 kilonewtons. 50 newtons. Sorry. It's achieved within the hour. So you can actually feel these slabs will actually stop rocking within the hour. You can actually you're standing there and the slabs are rocking, but within the hour they've stopped rocking. So National Highways are very pleased with this scheme, and it's gone very well. And there'll probably be some more repeat work coming there. If you need any information on this, we can certainly put you in contact with a contractor that does this type of work. There's a few case studies here. Now this one, because we're worldwide, Jamie gets given worldwide case studies. So this particular one was a port up in, I think that's northern Spain, and we used a product called Carbopor. They've got lots of titles and letters after them. There's lots of different ones, but the problem here was you had again, it's a case of reading it, or I'll give you the case study, but the actual the tides and the waves were washing out the actual stones, the actual rocks on the actual quay. So our product, it was down with an emergency repair and had to be done pretty rapidly. So they used a product called Carbopor, which was then injected from the top. It migrated through the rocks, and at the end of the day, what it's doing, it's actually migrating through and actually keeping those rocks together, so there's no further movement, and actually stopping the water coming in. So therefore, the pier and the dock area gets a lot longer life. This was an historic dock, so they had to do it, as it says here, with certain kind of historic kind of protection orders within Spain. Again, Minova would have worked closely with the contractor doing that work. Watford Rail Tunnel. This was done quite a while back now. In fact, a long time ago. But we work on a lot of rail tunnels. If you want any details on this, Nick has personally worked on lots in the last few months, actually. But the idea here is they're using cover stop product, which is the water stopping product. And this would have been where there was problems behind the brickwork and water. Either the bricks were falling out, or they were getting water coming through the actual bricks. Problem with the railways is as soon as you get any ice or icicles coming through the actual brickwork, this actually causes problems to the trains operating, any loose bricks. So this is always emergency work. They try and do it as night shifts, but using resin is actually a quicker process than taking out all the bricks, or sections of bricks. What you've worked on quite a few recently, haven't you, Nick? Any particular ones, tunnels you can think of offhand, or? Not offhand, right? Okay, he definitely has. No, I'm just trying to think of something. Curtain Tunnel, one of them's just come to Curtain Tunnel. Yeah. But also, as well as doing this type of work with the resin, a lot of work that Network Rail are doing at the moment is also filling the vertical shafts that come through the middle of the actual tunnels, and we've got a product that's been used quite a lot, and you've definitely done some of that because I know you have. I've seen the videos. So at the moment, Network Rail are actively looking for the actual shafts in the tunnels, but they've been bricked over, so they're having to find them by unbricking them. But they want these filled up all across the country, basically. So as they find them, we're getting contacted, and then we're going out to contractors to actually fill these in with a product we've got called Geofoam, which is the large void filling product, which is authorised by Network Rail to actually be used in these situations. Now, I've gone from filling voids to, so I'm still talking about the same product, but this is on a different scale. So this is the product, this is the case study. This was an emergency work done very recently, 2023, which was filling a huge void in a mine in Serbia. Where's the void size here? So there we are, 1,700 cubic meters of void was filled using a product called geofoam, which is fast expanding product. You can see the kind of an idea of how vast the area was. This would have been done with pumps, what they call SK90s, which are mining pumps, but we also use them within the construction and infrastructure sector as well.
Is there a strength to that?
There is a strength, but there isn't. There's minimal strength, to be honest, and it depends on how we can change the strength depending on how the actual foaming factor. But the idea of this, we've certainly got resins which have got lots of strength. If you want it to fill, if you need a particular strength, you tell us what you want, and we can find the resin. But this particular one is purely mainly for void filling, where you don't need strength.
What benefit does that bring then? What is the idea in the void being filled?
Well, there was rock. I wasn't actually involved in the project, but from what I understand, the major project problem was there was constant rock falling, which was affecting. I mean, they were filling out that void, but obviously they weren't using that void afterwards. So yeah, there is a question there about what they were doing for long term. But initially they needed it filled because of the amount of rock falling. So but I would need to find out a bit more about it for you, which I can do for you.
It's probably easier with that method, obviously, because it expands as well.
Yeah, that's right. I mean, certainly it was a big, very large project, and it was. I mean, that gives you an idea of the height there. And if you think that's being filled with a resin, it's quite very unique actually. And
so just reading your thing there, you've excavated through with this material. You can then excavate through it to put yourself I suppose personnel tunnel or something through.
Yeah, after they've done the actual,
yeah,
that's right. So it's because it's brittle at the end of the day. It's not like I mean, I can show you resins. We've got samples in our cars and that which are solid, rock hard. But this would just be a crumbly kind of. So yeah, you can excavate through it.
Is it environmentally inert once it's cured? Or
yeah.
Does it give off? Is there runoff? Is there?
No, it is inert once it's all cured. The all of our products have got we've got the full data sheets. They're all there's only one product which is probably used in the years ago in the mining industry, which we don't really use in this country, which we certainly wouldn't use within the construction industry, but everything else is all can be dug up if necessary. And we've got all the safety data as well, which we can provide you. But the idea of that slide really was just to show you the mass volume there of product. Nick's used this on the shafts, haven't you? So
The shafts, yeah.
So I think from memory, you did was it 60 cubic meters recently? About that?
Well, 18. Well, the 18 meter one. 18.
I'm just
18
guessing.
meter.
Yeah.
Depth, 3 meter wide.
Okay.
4 hours to build.
Yeah. So you can see how quick.
And is that done with two part mixers?
Yeah, it's two.
So
Yeah.
Each mix does. So when it reacts as soon as it's mixed.
Yeah, as soon as it's mixed, it reacts. Yeah.
How do you place that with a pump or some type of injection pump?
What, the geofoam into the shafts? Yeah, it comes down 2 separate hoses, and then mixes at the
On reception.
yeah.
The barn.
Pressure holes, is it, or it's just goes to before?
Pressure, yeah.
Pressure.
Okay. So that's that. I'll just jump over that one quickly because time is going quicker than I thought. So carbon stock 102. This is a product which is probably one of our biggest sellers in the UK. This was up in Corby, Corby, where the underground car park was getting flooded, and so a contractor that buys our resin was injecting. You can see you can see along here where they've injected through the sheet piles and actually stop the water flow. You know, it's not the prettiest of things. You will get some mess afterwards, but that all gets cleared up. But Corby Council were very pleased with that. We've been back there, in fact, twice now to stop the flooding on different areas. Another quick one there, Carbo Stop. They're all called Carbo, so the names do get confusing. But 42 is used for ground consolidation. Now, this picture is a bit misleading, but I was actually on site with this one in London. So this looks like you're actually injecting into the wall of the house, but it wasn't the wall. It was this was below the DPC. So they're actually going in. You went in 2 meters, didn't you? So we put in 2 meter lances underneath to actually stabilise the soil and the gravel that was underneath here. The contractor that did the work has now taken out all that brickwork, and then the actual soil has all stayed in place. So it was basically done as temporary works. Well, and then they're doing various other jobs in all this garden area. They're doing piling, but this was just the part we were called in to assist with. That's
question. Sorry, on that one, temporary works. Was there a temporary works design at all?
There was a temporary works design. Yeah. And there was a temporary works design, and the insurance company were involved as well, and they came along to site as well while we were there. So I'm getting close to the end of the presentation now, and but I'm just briefly going to touch on the geotechnical part of Minova. So like I said earlier, it's not part of the company I'm involved in, but I'm just going to show you a few slides of things that you may be interested in. If you are, then I can get our geotechnical manager to make contact with you. But we get involved in projects such as mesh walls. We actually, some of the products are manufactured, but what we do also as a company, we're kind of known as a one-stop shop. So people like Bam Ritchie's and Keller and a lot of the contractors will buy all the products they need off us rather than going around to lots of different companies to buy. So the mesh, nails, etc. Block set resins, these are held in stock in our Barnsley head office warehouse. These can be quite easily taken out to site, either in large volumes or in small amounts. I did actually go to this job briefly with our manager, geotechnical manager, and this was a project where we'd supplied down near Hastings. We'd supplied all the actual mesh, all the nails, and but not the labour. This was a Bam Ritchie site, so again, more of the same netting bolts. But you can see the kind of large projects that we certainly get involved with. And again, there's full technical support on this. There's also design as well. There's a team that helps with the design of these schemes.
Do you provide that design?
Within Minova, there's some of the design. Yeah, we either do the design or we will put you in contact with our designers. And then this is, I think, nearly my final slide. So, we've been involved on some sections of HS2, as you can see there on the Shilton Tunnel. This was all supplied, all the actual nails, all the mesh was all supplied by Minova on this section here. We were involved with Euston as well, but that stopped at the moment. But certainly a lot of money was spent on that, buying bits and pieces. But and there's we're still looking at a service tunnel at North Holt at the moment for HS2 as well. So we're still involved, even though obviously the scheme's changing, and but we are still involved. That's the end of my presentation. Just to let you know, I haven't done one for about 5 years, so I'm sorry if it was a little bit, hit and miss, but hopefully there is a few bits and pieces you've learned there. We've got all the case studies here, which we're happy to discuss with you outside afterwards. I'm here, and then Nick's here as our trainer. So he's very hands-on and can. I know Matthew wants to talk to you later on, and so on and so on. So thanks for your time, everybody. Thank you very much. Thank you.
Got any more questions?
Sorry. Any? Yeah, questions.
The resin
Yeah.
tubes. We're going to do some quite a bit on Darwin. Do you ever use Darwin? Or you kind of something that you, I know you do rock nails, but Darwin, there's different sizes. Do you get different?
I'm looking at Nick actually for an answer there.
For what, sorry?
Well, we do a lot of concrete Darwin. Rather than using just an injection resin, but using tube resin that you can spin.
Yeah.
To fix. You do.
Yeah, that's what that is, that box set.
Yeah, the capsules.
What's
Yeah.
what's the smallest diameters and you go to look where they all like
It's about 50, I think. I think that's the smallest.
We can check on that in a minute, can't we?
Yeah,
we'll have a check on that.
We're using lock set at the moment, and we're filling was at 38 mil.
Oh yeah, oh, right, okay. Thank you very much. Thank you.
Sorry.
Yeah. 25
None of
mil.
them do that, it's only 25 of them.
25 mil glass.
Just on the void filling
Yes,
or the sinkholes,
yes.
what products would you put into a sinkhole, and how do you know the size of the sinkhole? Because invariably they're different shapes and you can't see.
Yeah, well, I mean, as the manufacturer, we don't normally need to, you know, someone comes to us with who's done all this kind of investigation work, and they're just looking for the end product from us. So
already mapped and
yeah, that's right. But we've certainly got the products that can fill them. Depending on what the you know, it depends if you want strength in it. If you need strength in it, then you wouldn't go with geofoam. You'd use one of our other products. Which we'd use on the roads, and it depends on the size as well. But yeah, we've certainly got bits and pieces there.
Yeah.
But,
do you, with the contractors, do you have a system where you vet them, or do they have to apply to big contractors? Obviously, you're providing the material, not the job.
Yeah, well, what we do is to be honest, we won't just sell resin to anybody. You know, Nick's heavily involved in so. I would say a lot of our customers are existing large companies that are already in the UK and the Irish market. But if a new contractor comes on to us, then yeah, they will be vetted. They'll be trained by Nick. They'll come up to Barnsley, have a classroom training, site training, and then off they go. And then they'll be monitored afterwards as well. With
is there a cost to that?
There is a cost to that, yeah, but it's not a major cost because it's basically you're paying for Nick's accommodation, hotel and travel really. So you know, to come out to your site and things like that. So we're not we're not looking to make a profit. It's purely at cost to get him around the country really. Yeah.
Good morning everybody. Yeah, my name is David Headley. I'm infrastructure lead at Mainmark Ground Engineering. Yeah, my kind of role is kind of just overseeing, project managing kind of our B2B kind of projects, sort of on commercial from the infrastructure side. But yeah, just going to kind of run through a presentation on Mainmark Ground Engineering. Yeah, I'll kind of give you a bit of an overview about who we are and what we do. Talk about some of the kind of material safety and program benefits of the solutions that we offer. Go into a bit of detail about the actual products and technologies that we use. Talk about some previous project examples and yeah, just sort of summarise and take questions at the end, but feel free to jump in with any questions you may have as I go through. But yeah, Mainmark Ground Engineering, effectively we are a contractor that specialises in the use of kind of expanding resins, cementitious grouts, other specialist resins and grouts that really we use to kind of provide non-disruptive ground engineering solutions, kind of really as an alternative to the more kind of traditional, perhaps more disruptive solutions, such as traditional underpinning, piling, maybe even kind of full-blown reconstruction of structures. But yeah, Mainmark Ground Engineering is actually an Australian company, and they set up in the late 1980s. And then kind of over the years, as the company grew throughout Australia, they also set up a business in New Zealand, Japan, and then in 2015, yeah, they set up here in the United Kingdom. So yeah, here in the UK, we're based in Milton Keynes in Buckinghamshire. That's where our main head office and depot is. And then we've also got a depot on the south coast, just outside of Southampton. And then we've got another depot in Manchester that effectively we service projects throughout the UK, over in Ireland, and also mainland Europe as well. So we do undertake projects in like France and Spain, for example. But yeah, typically kind of what we are known for kind of dealing with is a lot of our work is subsidence work. So residential, domestic properties, but we also do a lot of commercial and infrastructure type works as well. So commercial sector, retail units, warehouses, and then kind of infrastructure. We deal with concrete slabs on roads, culverts, rail, kind of all sorts of projects really. But I think typically we're kind of known for subsidence, but we do get involved with kind of refurbishment works as well. So you may have an existing structure. Just say, for an example, you're adding an additional story on top of an existing building, increasing the loadings on the existing foundations, resulting in a load increase and therefore a requirement to underpin the building. Or rather than that, we could utilise resin injection to improve the ground, to improve the parameters of the soils to facilitate a load increase. So we do that kind of work as well. But talking about subsidence, we kind of deal with a lot of defective drainage, clay shrinkage. We get involved with mine workings, filling up of voids. We kind of do slope stabilisation as well, doing slip planes and that kind of thing. In terms of what we kind of actually use and what we do and what I'm going to talk about today, kind of the first products that one of our first standard products is called TerraTech, and this is basically expanding geopolymer resin. And we use this for kind of stabilisation of foundations. We also use it for lifting, level correction of foundations and concrete slabs. And we use it for kind of ground improvement, so actually improving the parameters of soil.
You done any work at the airport?
Yeah. I've got a little slide and a picture showing a bit on that. That's the TerraTech. So I'll talk a little bit about that. And then we've got another product called JOG, and this is basically a cementitious grout that we use for kind of complex, large-scale kind of level correction of subsided buildings. So I'll talk a little bit about that. Just to make you aware, we've got another product called TerraFill, and this is basically a foam concrete that we use for void filling. We have other resins that we can use for void filling. We've got access to Minova resins that we can use for void filling, but it just depends on the project, what the design or the specification is. We'll decide what material is best. We also do permeation grouting as well, and this is where we inject ultrafine cement into kind of granular soils, basically to stabilise soil, and that might be to facilitate excavation, to prevent water ingress, to allow excavations to happen, basically. And then just generally as part of our works, we do kind of full range kind of building monitoring.
Testing as well. You do the testing of soils as well.
So I'll talk a little bit about that as well. I'll talk a little bit about that as well. That's kind of like an overview, but basically any job that's specified for any particular product, as long as we can get our hands on the product, is a project that we'd look at doing. So kind of starting off with TerraTech then, so this is the expanding geopolymer resin. So effectively this is a two-component material, resin and hardener. But as soon as these two components meet, which is just at the point before it's injected and delivered into the soil, basically chemical reaction, two components mix, they kind of expand, and as it does so, it then cures into its kind of final product. But generally we use this for kind of stabilisation of foundations or concrete slabs. We can use it to lift concrete slabs because this resin is expansive, and then we can actually inject this material at depth into the soil and use the expansion of the material in the soil to actually compact and consolidate soil to strengthen soils. So with these TerraTech products, there's about 30 different resins in total. Probably out of those, there's maybe 4 or 5 that we most commonly use, and they all have slightly different attributes in terms of compressive strength, density. But we've kind of specified a particular resin that's most suited to, achieve a certain spec. But talking about compressive strength, their strengths range from about 150 kPa up to about 3.5 MPa in terms of compressive strength. So some of them do have some good compressive strength. And then talking about densities, these materials are very, very lightweight. So they can range in density from like 50 kilos per cubic meter up to maybe 350, 400 kilos per cubic meter. So they are very, very lightweight, and there's a benefit there when we're doing void filling, so we're not inducing a load of extra weight into an existing void. So a few key things to mention about these resins. So they cure very, very quickly. So generally they kind of cure within about 30 to 40 seconds of being injected. So if you imagine us injecting a resin underneath a concrete road slab on an A road or a motorway or a taxiway at an airport, because these resins cure so quickly, effectively there's minimal downtime. So effectively once we've stabilised or re-leveled a concrete slab, it can effectively be trafficked immediately. There's no kind of waiting for soil source.
How do you do the lifting? Is it through the liquid that actually exposed?
Yeah.
How do you control that?
So when we're injecting, we monitor the whole area as a standard with laser receivers to 0.5 mil accuracy. So effectively we can control lift as a standard to 0.5 mil. We've done jobs in the past where the tolerance is even finer than that, like microns, and yes, it's very, very controlled, and the risk of overlift is almost minimal. So, but yeah, so I've spoken about them being, kind of compressive strengths and the densities, but the resins themselves are not affected by kind of temperature in any way, shape or form, so we can kind of, we can deliver these works all year round, kind of external temperature, weather doesn't have an impact on the delivery of these works at all. Talking about sort of health and safety, product health and safety. So yeah, these materials are completely inert. Once they've gone off, there's no risk of contamination to water table, adjacent water courses. It's a completely inert product. It can be excavated and disposed of. There's no special requirements in terms of waste disposal in terms of these materials. They are long lasting and durable, design life of in excess of 100 years. So yeah, they are long lasting. Talking about kind of guarantees and things that we give, kind of generally as a standard, we offer kind of 20-year product warranty, which will basically be saying there'll be no shrinkage, deterioration of the injected material for a period of 20 years. Depending on the nature of the job, what the requirement is, we look at workmanship, design, all that kind of thing as well as part of the offer. Kind of more
technical side of it? You do the GR? Or do you do
where we don't have in-house capability to do that, but we can sub that out if but I'd probably say on a lot of jobs it's already done for us, and we're provided with it. Kind of more applicable to the residential sector, but we do 10-year insurance-backed guarantees and certificates of structural adequacy. So certificate signing off the job, and it means new purchaser of property could get a mortgage and insurance and all that kind of thing. But yeah, so what do we actually use Tech for? So first of all, they have kind of stabilisation and re-levelling. So this is generally ground-bearing concrete slabs. This could be a residential slab in a property, be a vast area of concrete slab in a warehouse, or concrete slab on an A road or a taxi route in an airport. We then have kind of ground improvement. So this is where we're injecting the resin at depth underneath an existing foundation. This could be to remediate subsidence, or it could be for refurbishment works, facilitating a load increase. We improve the ground to take the load. And then we can use these resins for void filling as well. As I say, we've got the product, the TerraFill product, which is the foam concrete. Got access to Minova stuff if we need. But yeah, it just depends the nature of the void, the size, economies of scale as to which one's the best in terms of pricing and all that kind of thing. But yeah, we can do void filling as well. So just to give you an example of, when we mobilise the site, what does it look like? What do we actually turn up in? So this is one of our rigs, so 10-ton rig, self-contained vehicle. All the material, plant and equipment is contained within that. And effectively, we just need to get this within about 75 metres of where we're working. Basically, there's an injection hose that pumps the resin. Kind of as a standard, the maximum length of that hose is about 75 metres. If there's really tricky access, we can extend the hose, can decant all the equipment and onto vans or something, but yeah, as a standard, this is what we turn up in. But if there's really access problems, generally we can work around it. So I'll just kind of run you through how we deliver kind of slab stabilisation and re-levelling. So this kind of example here is ground-bearing floor slab in a warehouse. This job was done a couple of years ago up in Burnley. So yeah, commercial warehouse, and basically the floor slab has dropped. There's racking basically off the floor slab, and also where the floor slab's dropped, the racking's uneven. So if you imagine forklifts trying to pick pallets off, it's a bit of a problem. I guess the traditional solution area is going to be, reconstruction, new piled slab, something like that. But obviously vastly intrusive, going to take a long time. It's going to be expensive as well. So this is really where the benefit of the resin injection system comes in. The reason the floor slab was dropped, by the way, is just this poor ground underlying the slab. It's consolidated, therefore it's allowed the void to form underneath the slab. It's not adequately supported, therefore it's dropped. But effectively what we do is we take a level survey. On some projects this might be provided to us, but yeah, we'll come out and do a level survey. We'll take a datum point, and then we'll just establish all the levels across the entire area relative to a datum, work out your required amount of lift. And also just to make you aware that if we know very precisely how much slab has dropped, we very accurately know how much resin is required to undertake a certain amount of lift. So generally kind of enables us to provide a fairly fixed quote, you know, and that kind of thing. But yeah, so we take a level survey. But effectively, what we're going to do is we're going to drill a series of 16mm diameter holes through the floor slab, and these are going to be drilled in a grid pattern at 1.5 metres centres across the entire area of slab that's to receive treatment. Once we've drilled all of these injection points, we then insert an aluminium injection tube through each of the holes. And remember, this is this grid at 1.5 metre centres. We've got our rig parked within 75 metres of the working area. We've got an injection hose running from the rig. At the end of the injection hose is an injection gun. We attach that to the aluminium tube. Before we pull the trigger and start injecting, we'll mount the laser receiver onto a staff, which is accurate to 0.5 mil, and there'll just be a rotary laser sending a signal to the receiver. Press 0, we know how much we want to lift this point. Pull the trigger on the gun, and then the resin is going to be delivered into the ground underlying the slab. Initially, what's going to happen is the resin will fill any voids that may be present. Within a few seconds, the resin is going to expand, and as it does so, it's going to compact, consolidate the existing subbase or fill material that's present beneath the slab. There'll come a point where the resin has filled any voids that are present, it's compacted the underlying ground as much as it can, but because it's still expanding at that point, it can only then start pushing upwards, and as soon as it happens, the laser receiver will flick up between 0 and 0.5 mil of lift. So once we get that flicker of lift, we know we've got support or stabilisation. So if we're looking just to stabilise the slab in its existing position, we stop and we repeat the process at the next injection location. And this is this 1.5 metre grid. However, if we're looking to lift the slab, once we get that flicker of lift, we know if we continue to inject, the only thing that's going to happen is lift. So we continue to inject resin goes in, it expands, it's going to start lifting the slab back up. We'll be monitoring that lift on the laser receiver as we bring the slab back up. And we just effectively repeat this process at each location. Now, depending on the severity of the drop, you're not going to lift 1.100 mil in one go. You might need to go in and do sweeps. So you might come in, bring every point up 5 mil, 10 mil, it just depends. But yeah, that's
pumping into each one individually. It's not that you've got a rig set and then you're pumping into all of them.
No, generally individually, yeah, but we do have some rigs with multiple injection hoses, so we can inject multiple points at the same time, and that may be beneficial, to be honest. Yeah, yeah, that's it. Yeah,
You said that you know exactly how much material.
Very accurately. Yeah.
Is that because you've been given a GPR ready for you?
Yeah, that's right. Yeah. So it's if we know how much the slab has dropped and we know how much we need to lift it, we know there's a volume there, so we know how much lift is needed, and we can work out how much resin. Obviously, we're relying on information to tell us if there's voiding, if there's loose ground that might alter, that might need more material. But it's very easy to work out how much resin is needed to achieve a certain amount of lift over an area. But yeah, so this methodology and approach would be very similar for any kind of concrete slab. This is obviously a warehouse, but concrete slab on an A road, motorway, or a taxiway at an airport. But the benefit of it, minimal intrusion, very, very quick. So in terms of from an operational perspective, what do we need to be aware of when we're on site undertaking these works? It's generally services and drainage. Probably more applicable in highways, but if there's a load of services present, obviously we're going to get the utility plans from the client or source them ourselves. But if there's a load of services, we'll get specialist companies to come in, do a survey, literally spray everything up for us. Because as a standard, we just do capture scanning. And then drainage, would recommend drainage surveys prior to the works being done to identify where they are, but also to identify if there's any pre-existing defects, because they should be repaired prior to the resin injection. And then, if we are injecting nearby any drains, we'll have drainage monitoring on site. They'll literally be monitoring the camera work whilst we're doing the works, just to ensure there's no resin ingress. If the resin does get in, we see it, stop injecting within 30 seconds of resin is cured within the pipe, and then we just jet it out, basically, ensure the pipe's free flowing. But yeah, in terms of what do we need from the client, what investigatory work do we need? Level survey, that's something we can do ourselves. I'd say cores are pretty important, so we know the slab thickness. Is there a load of reinforcement there? Because if we need to lift a slab 200 mil and it's only 50 mil thick, we're going to crack that slab. So cores, and then it'd be nice to know if there's voiding present beneath the slab. What are the underlying ground conditions? So this is just a typical example of kind of rocking concrete road slabs. So you can see on the left-hand side, it's the vehicle's driving over the slab joint, it's rocking. There's no doubt we've got water ingress on that joint there, so that will need to be sealed as well. But we've come in, resin injection, level stabiliser slab, you know, and it's very, very quick. And I guess traditional solution there, you know, unless you're just going to put something in there just to, you know, make it safe. But if you just do one drill out, it's an hour's work, you know, it's very, very quick. Yeah, yeah. I'd say a typical crew, which is like one rig, 3 operatives, probably do like 300 square meters in a day, typically in terms of area. But, you know, if you've got a vast area of road, you know, we'll just have multiple rigs, multiple crews just working just to increase the output. Yeah, so that's kind of stabilization and releveling kind of slabs. Just talk a bit about ground improvement now. So a lot of the stuff we do is subsidence, so subsiding structures. So we do a lot of residential, you know, insurance work. We do private residential works. But yeah, any building or structure that's subsided, you know, you can have, yeah, bridges, you know, roads, you know. But yeah, where you've got a requirement for you know, undertaking ground improvement, improving bearing capacity of the soil. So generally with subsidence, you know, the soil's been compromised by maybe defective drainage, clay shrinkage, resulting in a loss of bearing capacity. You've got a foundation built on top of that, the soil can't take the weight. So, you know, the building or foundation drops, resulting in some form of, you know, underpinning, be it traditional underpinning or piling. Well, rather than that, we could utilise resin injection to provide ground improvement, inject the resin into the soil, improve the strength of the soil, essentially increase the bearing capacity of the soil to allow it to take the bearing pressure from the foundation. So, yeah, subsidence, but then refurbishment works as well. I'll just give you an example. You know, you might have an existing concrete slab in a warehouse, you're putting in a mezzanine floor on top of the slab's not adequate. Well, at each of those column locations, rather than putting a little concrete pad, you know, we do resin injection, you know, improve the ground to take the load. So that's the sort of projects we do. But yeah, the approach in terms of the delivery, very, very similar, but generally we'd be provided with, or, you know, generally we get provided with site investigation, trial pits and boreholes. So trial pits are important, so we know the type and the depth of the foundation, and then boreholes to confirm the soil conditions. And then within those boreholes or window samples, there might be some kind of DCP testing or N values. Effectively, what we're going to be looking from that is kind of the depth underneath the foundation at which the soil basically becomes good. You know, you've got firm bearing, be that 1, 2, 3, 4, 5 meters beneath the existing foundation level. And then we would undertake ground improvement via resin injection from underside of foundation to that depth, be whatever that depth is. But effectively what we do is we drill this 16 mil holes again, but we then drill kind of multiple, this is one method of doing it, but you might drill multiple depths. So you drill to 1, 2, 3, 4 meters beneath the foundation. And then you have kind of 1, 2, 3, 4 meter injection. You inject each one individually. So effectively at a depth of 1 meter beneath the foundation, you inject the resin, it goes into the soil, the resin expands. As it does so, it compacts and consolidates the soil. If you continue to inject resin, there's just going to come a point where the resin can't compact the soil anymore. It's going to start pushing upwards against the underside of the foundation. And then again, we'll be monitoring with the laser receiver. As soon as you get that 1/2 mil flicker, we know we can't get any more in without getting lift. So you stop, and then you repeat the process at the next depth. You keep injecting until you get that flicker of lift. And you just repeat that process at each depth. It's not always necessary to get lift at each depth, just as long as you get enough resin in to provide the required amount of ground improvement. So as part of these works, we would undertake pre and post dynamic cone penetrometer testing. So effectively we'll have a rod with a cone on the end of it. There'll be a plate on top of the rod, and there'll be a 30 kilo weight that drops on the plate, and in turn that drives the rod into the ground. And then we just count the number of blows of the weight to drive every 100 mil into the soil, and we'll get a blow count per 100 mil. We do that pre-injection, and then post-resin injection, there'll be an improvement on the blow count to say, yeah, we've improved the ground, but also the spec of the job might be the ground needs improving to 200 kPa, something like that. And we get that blow count, and then we can tell you, yep, if you convert it, so we've improved the ground into what it needed. Yeah.
And that's your design.
Yes.
That's your design.
Yeah.
So that's your warranty then.
Yeah, that's right. Yeah, yeah. But there's some jobs. So this is like it's standard in-house equipment that we've got. There's some jobs, you know, it might be new CBR test or something, you know. So we'd have to get in someone to do that for us or whatever. But yeah. But yeah, so I've been kind of talking about foundations really, but yeah, on the infrastructure side, yeah, we kind of do sea walls, you know, doing the sinkholes with using this kind of methodology, bridge abutments with roads, all different kind of projects really. So I'll just run you through some previous projects examples now. So yeah, where we've used the resin. So this was a Curry's warehouse down in Newbury. Basically ground bearing floor slab, it dropped. Needed a solution. So the benefit of what we ended up doing here was, so this was obviously a live kind of retail store. We came in night shifts, and basically, injected resin injection to stabilise, re-level the slab. But between the night shifts, the store was completely open, operational during the day. So effectively, there was zero interruption to their business. Whereas obviously, breaking out that slab, new pod slab or something, you have to close the business. It's going to take months. Whereas we did the job in 2 weeks, and it's kind of between our shifts, the place stayed completely open. This is just an example of kind of a refurbishment job. This is in Ampthill in Bedfordshire, but this was like this is an NatWest bank here. Anyway, they'll do a refurbishment of the existing building, and as a result, increasing the loadings on the existing foundations of this property, resulting in a need to underpin. They did some window samples that identified kind of loose sand, kind of ground conditions down to a depth of 2.4 metres underneath the foundations. So any traditional underpin was needed to go down to 2.4 metres. But problem here was like the frontage of, you've got strip footing kind of just behind there. The building's right adjacent to the public highway. So it kind of means all works need to be done internally, but it's kind of limited access to, equipment. What we did is we did resin injection, did ground improvement, injected resin into these loose sands, used the expansion of the resin to compact and consolidate the sand to increase its bearing capacity. And as part of the works, we did the pre and post penetrometer testing to verify that we improved the ground to the required values. But that was about 45 linear meters of foundation, about 5 concrete pads that we treated as well, done in about 7 or 8 days, I think. Just to give you an example, it's kind of residential, but this is very typical terrace property in London. Got a little addition at the rear of the building, suffering from subsidence, needs underpinning. Traditional underpinning there's no access, literally access into the gardens through the front door. So, it's not going to be done, basically. So the benefit of what we do, self-contained vehicle, all the plant material and equipment, literally pull off by hand through the front door and complete the works in a couple of days. So that's really on the residential side why the system's so beneficial. Just some other kind of stabilisation concrete slabs. So this is Belfast Airport here that we did a couple of years ago. So we've got these little kind of pad slabs here that are dropped right on the taxiway. So literally didn't have to close the taxiway for us. We came in between planes here, had like an hour window to treat one slab. We did it, came off, stabilise, planes go over, and then do the next one. So that's really the benefit of it here. So in normal, what you can do, full day replacement, and it's out of action for however long.
Could have done what you did that probably about 20 years ago.
Right, yeah. And then these, this is all in Oxford. So they got a drone out to take these shots. But so we've got obviously an overlay on top of the concrete here, but you can see here you've got reflective cracking at the joints where the slabs are unstable. So if they can surface stress, they can resurface that road, but the concrete slab is still unstable, so it's not a loss. So we come in, we inject resin. This is the 1.5 metre grid. We inject the resin, stabilise the slabs, and then what they will do when they get the budget at some point, hopefully, is then they'll then resurface the road, knowing the slabs are stable.
Problem is it will do any good reflective cracking still.
So unless they do some kind of glass grid over the top, I don't know to stop that, but I don't know. Slabs are not stable anyway. I suppose again the normal thing there. I mean they're not going to rip that road up, So obviously these are just kind of residential roads, but fairly easy doing these works under a road closure. But it's Belfast. Just some other examples of jobs. This is another job in Oxford actually, but this is like a waste recycling centre. Basically what we've got here is like there's not really a road built up at all, but effectively you've got, maybe a thin layer of asphalt, and then under that it's just a load of fill material kind of made ground. There's lots of drainage here. It's kind of all defective. There's all the water's escaping, and as it's escaping into the made ground fill, it's just kind of washing it away, creating little voids. What was actually happening is they'll get little mini sinkholes through the road surface. The asphalt was just collapsing on itself. So anyway, they'd had this problem a few years ago, and what they did previously is they just got a load of concrete poured into the hole. But just on the outside here is a little stream. Concrete found its way through into the stream. So when the issue kind of arose again, just wanted a bit of a different alternative. So we ended up getting the inquiry. And the benefit of our system is because, I think I've actually explained this earlier, but from the point of injection, the resin can only travel about 1 to 1.5 meters in all directions. The reason it can't travel any further is because it goes off so quickly. So after that kind of 1 to 1.5 meters distance of travel, it's gone off, cured, can't travel any further. So we knew that when we inject here, there's no risk, basically. But yeah, we just went in. Yeah, so one of our technicians that were doing John. But yeah, went in, just filled all those voids, basically, stabilised the grounds.
So it works. All staying in.
Yeah, no, that's it. Yeah. This drop down is that's what I was speaking to someone about this job in Glynny failure. South Wales, near Swansea, Waterboard are putting in a culvert underneath the existing road. So putting the coffer down, and then they're excavating a tunnel underneath the road, pushing the tunnel through. The
social park, social club.
Yeah, that's it. So I can't remember the diameter of the tunnel, maybe it was 1.8 meters, but the crown of the tunnel was about 2 meters beneath the existing level of the carriageway. Anyway, as they'll literally excavating by hand, basically there was a bit of settlement on the road surface, and then also as the ground was very loose, cobbly type ground, as they're excavating, we'll get a lot of collapse. We were asked to see if we could come up with any kind of solution to stabilise that ground, to limit settlement on the road, but also to prevent the collapse of ground, to make the excavation easier. Not something we really do with with resin injection. So what we ended up doing is we went and did a small trial kind of in a nearby field. We pitched 2 different resins that we thought might be suitable. We injected kind of 2 blocks of ground, and then they excavated around to kind of see how the ground held up, and one of them worked really well. So what we then ended up doing is about 100 meter length of this culvert, as we actually injected resin ahead of the excavation, literally right over the crown to the sides where the tunnel was going, and it basically enabled that excavation then to take place with, we couldn't guarantee there'd be no collapse, but yeah, exactly, yeah, but it worked surprisingly well, actually. So sort of thing again that we'd look at. This is like obviously a bridge approach here. What we, obviously before you hit the deck, you've got behind the abutment between the wing walls, you've obviously got a depth of material. If that was to consolidate, we often seen jobs in the past with animal sets getting behind the wing walls and things. Obviously that creates a void. Therefore that, all that material on top is going to drop. Rather than, I suppose the full solution, all they're going to do is resurface the road, but eventually it's still going to drop. But rather than mass excavation and replacement of that material, we can inject resin to void, compact, consolidate the ground. It will become stable basically, so we can do that kind of thing. Also, this is the DCP testing, so this is the 30 kilo weight which drops on the plate, and in turn that drives the rod into the soil. We just count the number of blows for every 100 mil penetration. This was void filling that we did, kind of void filling and ground improvement that we did with the resin. So this is Scarborough railway station. This is the platform here. There's a glass roof overlying the platform. They're doing some maintenance on the glass roof, and to enable them access, they're putting like a scaffold structure on top of the platform. So each of these boxes is like where a little scaffold base is going to be built off the platform. But basically the platform in places is literally suspended. So this is what's underneath this kind of void. In other areas, it's just kind of loose, cobbly made ground. But obviously the risk is here, each of these bases, which is a load of 100 kPa, if they place it on the platform, risk of collapse. Originally, they were looking at putting like a 1 metre deep concrete pad at each of these locations. First off, the cost was quite large, and then also it's a timescale and disruption to the station. So what we ended up doing, we injected. So it wasn't just all voiding, by the way. Some places was like loose. There was actual ground that we're injecting into. But each of these locations, we basically just drilled around the perimeter and through the centre. We injected resin to stabilise the ground. Ultimately, we just needed to give them 100 kPa in terms of load bearing. But we did this job on night shifts. I can't remember how many crews we've got on it, maybe 3 or 4. Worked over consecutive nights, but had that job done in 4 working nights, basically, with effectively 0 disruption to the station. Right, so that's Teratech resin. I'll just briefly talk about JOG now, a completely different solution, completely different product. So this is a cementitious grout that we use for large-scale, complex level correction of subsided structures. So we can use the Teratech resin to lift up a porch, lift up the side of a conservatory, lift up a concrete slab. But if this whole hotel that we're stood in, if this whole thing had dropped 200 mil, that's where we'd use this system. But effectively, cementitious grout. the kind of the theory is here that is what we do is core 40 mil holes. We insert an injector. Each of the injectors that the grout is pumped to is connected to a valve, and then the valve then is connected to a pump, and the pump is controlled by a computer. But effectively, each of these numbers here correlates to one injector. But basically, we can inject multiple locations all at the same time. But yeah, what we actually do is when we inject this grout, we inject about 300 mil at a time. So it's a very, very small amount. But what happens is when you inject about 300 mil underneath the foundation, this grout cures within about 1 second of being injected. And what happens is you create a very, very thin layer of cement. And then you inject another 300 mil, and again, you create a very, very thin layer of cement. But as you continue to inject, you basically build up these layers. And as that happens, simultaneously at multiple locations all at the same time, the building is basically gradually floated up out of the ground. This is kind of a sample of the cement here. So you can see those layers, and it is basically those building up of those layers at multiple locations that is, jacking off, floating the building up out of the ground. I'll just show you this video because this is quite good. So this just shows you how quickly it cures. So you can see it's pretty much instant, but it is that instant set that creates the layer, and then you continue to inject and you build up. But effectively it's cement and water, and what our technical manager calls a few herbs, which we're not allowed to be told what it is. Yeah. So this is injected at very high pressure, by the way. So those injectors literally need to be locked and tied into the foundation, because if they're not, there's a risk that they'll just blow out when you inject this stuff. So anyway, we can amend the mix slightly to allow it to set over a longer period of time. And the reason for that is once we start getting lift inherently between the injectors, you might end up creating voids where that cement hasn't travelled. So we then inject the longer curing cement, which will then permeate and kind of fill voids up, basically. And you just keep injecting that until you start getting pressure and lift, which kind of verifies the build it. Yeah, that's it. I'll just talk to you about a job where we did this on. This is in Barnet in North London. Just to make you aware, the company won a Construction News Specialist Award for this job last year. This job was done, I think, in 2021. These two neighbouring residential block of flats, so not iLine, but these are right next door to each other. They were built in, these buildings were built in the late 1990s. Prior to their construction, this land was just a load of elm trees. But anyway, so prior to their construction, the elm trees were felled and these residential block of flats were constructed. A few years after construction, building A here, it was noted that there were quite a lot of cracks appearing in the building. Insurers were notified, they did a period of monitoring, and it was determined that the building was actually suffering from heave. So we've got London clay underneath associated with those elm trees that were removed. The ground is now recovering, pushing the building up out of the ground. Anyway, long process. Eventually what they ended up doing was moving everybody out. They put in a new piled raft to effectively support and stabilise the structure. They completely stripped out the entire first floor, put a new level first floor in, because obviously the building's now out of level. But if you did a brick course level survey here, that's still going to be out of level, but it's now stable. Anyway, it took, many months, vast expense. All the residents moved back in, and it was job done. Anyway, it was then noticed that building B, right next door, was also noticed a few cracks. Now, the cracks in building A are actually quite bad because the building just moved all over the place. But they noticed some cracks here, but they weren't too bad. But anyway, they did a survey, and they determined that building B had also suffered from heave as well. But the cracks weren't so obvious because the kind of building had moved up fairly uniformly. But effectively, this end of the building here had risen up out of the ground 140 mil relative to this corner. Anyway, gone for insurance again. Solution needs putting in place. So originally what they were looking at doing is doing a similar scheme to what they did here. They're going to put in a new piled raft to support and stabilise the building. Then they're going to mechanically jack the building off the raft. But again, vast expense, fast time, residents all moved out. Anyway, the engineer on this job used to work in New Zealand, knew of Mainmark in New Zealand. Anyway, he got us here in the UK involved. And yeah, what we ended up doing was using the GOG system to basically lift the other end back of the building so it was level. So, this building hasn't subsided. One end is lifted. We're coming in to lift the other end to bring it level. But yeah, so we did the GOG system. And the real benefit of this particular job, is that the residents on the first floor didn't have to move out, so they were literally living in their house, sleeping at night, you know, whilst we were lifting the building. So yeah, so I think that's quite one of the award. But anyway, the joining took 17 days, whereas, and you know, vastly reduced cost compared to the 270 for the alternative solution. But it's not the best time-lapse video, but this is just a typical day that you can just about see the kind of roof line moving away from that blue line there. But it is a very, very slow, gradual lift, but effectively injecting multiple locations all at the same time. You know, we can monitor lift just with those 0.5 mil flicker. You see this here, you know, we'll have a full Trimble total stations, you know, measuring, so we're getting constant live feedback, because, yeah, we need that to know where to inject relative to other places. Yeah, and that pretty much brings us to the end, really. So yeah, residential, commercial, infrastructure sectors, all sorts of projects we get involved with. We've done a little bit, yeah, to be fair. Yeah. No. So yeah, we have done a few new builds. Yeah, we do a lot of insurance work. Yeah, on the residential side. Yeah, as well as private residential work, and then we do local authority housing as well. Yeah. They can range from like 3.5 grand up to like a million, up to $1 million. Yeah. Oh yeah, we would. Yeah, so on the residential side, yeah, we know we might come out to do a porch, you know, which is a day's work, or yeah. So the residential stuff is what we call like our gap jobs. You know, we've got big jobs that we could be on for months, and then yeah, we'll have gap, you know, the kind of 1-2 day jobs which kind of fill stuff in between, really. Yeah. So really I only spoke about TerraTech today and a little bit about GOG at the end, but yeah, we've got void fill materials. We do this permeation grouting. This is a fairly new one now, what we're doing, but just bear that in mind. If you need to excavate for some reason, you know, we do jobs where we do a full-on temporary works design to, you know, ensure the ground will hold up for a period of time after we've injected it. So yeah, we do that as well. So just contact details. This is Milton Keynes. So yeah, basically Milton Keynes and Buckinghamshire. Then we're just outside Southampton. We're also in Manchester as well. But yeah, that's the end really. So I'll take any questions should there be any. Yeah, I'll be hanging around obviously for the rest of the day. So.
Just on the warehousing comment, do you not have to take the racking and the shelving down? We can do
No. Right. We did a job in Cork in Ireland last year where literally the racking, all the pallets are on, you know, and, we lifted it.
So morning. My name's obviously Nick Sheehan. So I'm one of the directors of iLine. I've got some good and bad news for you. The good news is I talk very quickly, so this will be over very quickly so you can get away. Bad news is that whilst my name's on the sort of screen there, this is Jason's presentation, and me being me, looked at this morning for 5 minutes, went, yeah, I know what I'm doing. So we might be going backwards and forwards, we might be repeating things, so apologies on that point of view. So who are we? We are pretty much a little bit different from what you've seen previously this morning. We rehabilitate culverts. We do pipes as well. I mean, pipes, culverts, in a way, it's all the same thing. We tend to stick to larger diameters, just it's a little bit more of our specialism. Based in Northampton, we have a depot in South Wales, but because we're very specialised, we work all over the UK. So anywhere from, let's say, the Shetland Isles, where we've worked for BP, all the way down to the southeast, southwest. And wherever the work is, we will go. And the sort of things I'm going to talk to you today about: UV GRP cured in place liner, which is this material here for rehabilitating pipes, and then GRP, preformed GRP, which is this sort of material there. But hopefully we'll go through it quite quickly. Any questions, feel free to sort of shout them out as we go along. So what do we have the problems with? Things like structural failure, so developed through fractures, cracks, deformation. Obviously that goes into aging assets, and even faulty joints where maybe they're not being constructed correctly. And then ultimately you're going to get blockages, you're going to get collapse, and you're going to get issues above ground. So that's the typical sort of thing, a little bit extreme, that we start to get involved in. People come on to us to talk about what can I do with this aging asset. This again is a culvert in, let's say, South Wales. I'm not sure where it is. It could be under a railway, it could be under a road. I'm not 100% sure, but that's the type of thing. Obviously, concrete pipe. A lot of the things we do are brick, stone culverts. We do quite a lot for Network Rail, so a lot of their assets are old brick culverts that were built however long ago railways were built, which is what, 120 years ago, I guess, something silly like that. And these are the sort of things that we rehabilitate. Obviously, the types of pipes can be, as I mentioned, foul surface water sewers, combined sewers, culverts, which is where we tend to sort of stick. And again, all sorts of shapes. Unfortunately, very few are nice and circular. We get all sorts of eggs, ovals, arch, rectangulars, all sorts of things. And anything from, in effect, 150 millimetres all the way up to 7 metres in diameter. And these are the sort of typical sort of shapes and constructions. Armco culvert on the left. Not what that is in the middle, but sort of brick and sprayed. Similar thing on the right-hand side. Weird and wonderful sort of constructions that people have made over the years. Okay, so how do we get involved from the start? We very much are one of these companies where we say to people, tell us what you've got, let us have a look at it. If it isn't right for us, we'd hopefully tell you at that point it's not the right way to do this, you know, you're better off digging it out or some other method. Because I think all these solutions benefit from early contractor involvement. If we can have a look at it first before we go too far down the route of suggesting something without knowing what we're doing. So we offer a full design service, so we will come and look at the jobs, we will design the jobs. And what I mean by designing the jobs is we'll do sort of, people have different forms. So Network Rail have, I mean, it's only this 1, 2, 3, but it's now A, B, C, Form Gs. You have the highway who have the AIPs, the approval in principles. We will do all of that. We will then select a rehabilitation method. We will design it. So when I talk about design, I'm talking about taking loadings from things like LM1, LM2, Railway LM71, those sort of loads. And we will come up with a package of a design that says this is how it's going to work. We'll also look at things like flow calculations, because again, that's critical. You might be having to obtain, which on most occasions you're having to obtain ordinary watercourse consent from the lead local flood authority, or you're going down the main rivers and you're going down the EA approval. So all that we do, we get involved in. And to facilitate that, we're going to do things like sort of topographical surveys, ecology surveys, to put all that package together. So the first sort of product that we use is what's called a cured in place system, which is this type of material. And you can see on the picture there, and a lot of the pictures will be pipes. I think, remember rightly, up to this morning at 8 o'clock, only because this product is pretty commonly used in the water industry. So your likes of, sticking around here, Wessex Water, Severn Trent, South West Waters, Southern Waters, those sort of people, and Thames Waters. That's where the vast majority of work is for that sort of thing. So what determines the type of liner that we're going to use? So again, what's the thickness? And we vary this liner in thickness from anything from 3 millimeters all the way up to 30 millimeters. And that comes pretty much from your loading. And depending on what you're looking to try and achieve, are we looking at just designing this liner to take the hydrostatic load? So again, a lot of the water companies will look at just hydrostatic loading, because they will argue, rightly, into a certain degree, that the pipe's still there. It's still circular, it's still standing up. The issue we've got is leaking joints. So in a way, all we need to do is protect the existing asset and stop this water coming in, which erodes the outside of the pipe, brings roots in. So all we need to do is design this liner to withstand the hydrostatic pressure, because the existing pipe is going to take the loads. And some people call that a partially deteriorated design. Some people call it a WRC Type 2 design, which is the Water Research Council. So we just got to establish what we're trying to achieve. And from then we take things like the live and dead loads. So for instance, Network Rail look at a fully structural liner, in effect, ignoring what you've got there. So we take loads from the Euro codes, which in particular for railways would be LM71, for highways, LM1, LM2, LM3. And we design that loader to take all that load, that liner to take all that load. Other things that affect us are ovality, the diameter, obviously the diameter, the bends. So again, some lining systems are better at bends than others. So this UV system is not a great lover of bends. Certainly 45s and 90-degree bends it does not like, and won't be efficient and work for. So we have to look at a different system. Again, things like the effluent, what is it? Is it trade effluent? So again, the inside coating of the material needs to be developed to combat any chemicals. And again, things like the temperature, that also has a point. And we make the comment there about the flow characteristics. So when we're looking at EA consent or ordinary waterboard consent, how much flow can we get through this newly lined pipe? Because obviously you've got a reduction in cross-sectional area, and that has an impact. And especially the EA and the ordinary water course consent don't want to see a liner going in, and then you're going to create flooding upstream because you've reduced the cross-sectional bore. And one of the arguments on that side is the smoothness, and this is where we talk about the roughness coefficients, the Mannings and the Colbert Whites. It's a very smooth material. So cured in place, which we've talked about. Sizes and shapes, I say we can do any size and shapes. The largest we can do with this cured in place currently is 2 meters diameter. I don't like it. It's very, very hard work. And there's a lot of risks involved, but the system works. They have been done. We as a company have done up to 1800 diameter. I think there might be a picture of that later on. We can do squares because ultimately what we are interested in is the circumference of the whole structure, because this material comes, again I'll show it in a few minutes, flat packed like this. So it's inflated with compressed air, so it forms the shape of the existing structure. So if you've got a square box, it can do a square box. The issues come when you start doing the design on this. It's easy doing a design on a pipe because you've got that circular shape, that arch. When you've got a flat sort of surface there, roof, then obviously it increases how thick the liner goes, and these liners can only be made to a certain thickness in effect. So again, a couple of different little examples, all sorts of weird and wonderful shapes on there. And again, you've got a box there. You will see coming up quite a lot, and you can slightly see it in this, that we've actually put a circle in that box. And we're often asked why we do that. Again, it comes down to things like design. If we put a circle in, we're going to have a thinner wall thickness. We then grout the annulus around it just to take the loading from the road or the surface onto the liner. That grout's just there as a void filler. And because the roughness coefficients of things like an old stone box culvert are so poor, you sometimes find that a circular liner will give you the same flow through as you had with that old box. So how are these cured in place liners made? The ones that we particularly use, which are cured by ultraviolet light, are made in a factory, generally in Germany. There's about 5 suppliers of this material, all based in Germany. We use 2 of them. Why? Well, we like their product. They're all very similar. It's just we prefer these 2 for various reasons, installation methods more than anything. The pictures that you've seen up here and maybe see in a couple of minutes will be a company called iLine Europe, who we use quite a lot. We've used iLine Europe since they started in business, which was 14 years. Now I think they've been going on 15 years. Prior to that, we used another company, another German company, and we used those for about 16 years. So we've been installing these lines for nearly 20 years now, something along that lines. And they're made up of a glass fibre matting. So you can see here, this matting, it's 0.7 millimeters thick is each layer. And each layer is impregnated with a resin. So this is the resin going in there. And then what they do is, hopefully on the next picture, no they don't, what they do is they wrap it into a toilet roll. So in a previous photograph, I'm just going to go back, that was it, no not that one, this one. You see this and you sort of think, oh, is it a ridged pipe? It's not actually, it's a bit of an illusion. That's actually the wrapping of the material. They've wrapped it to get it to the thickness that I've told them I want it. I want it 5 mil thick. So they'll wrap the 0.7 mil layers, I don't know whether that is, 7 times. Until they get to that thickness or whatever that thickness is. And it just creates that illusion of a toilet roll in effect. So you see here 0.7 mil thick, seamless construction because of the toilet roll effect. And that's why they went down this route, this particular supplier, because they could get higher strengths. This material, you'll see there's different colours on the back. This is a different supplier to this one. These guys just wrap it over, which is just, it's very strong. It's not as strong as this. We're talking minimal amounts, but it's not as strong. So
the resin is impregnated.
Yes.
Is that something that dries and it only sets when it's UV light?
Yeah, it is. So as long as, and again, you'll see some pictures coming up, as long as that, once that toilet roll's wrapped in the factory, and I've said to them, right, I want 30 meters, 900 diameter, 10 mil thick, they will wrap that up to get to the right sizes, and it will come to me in a box. like a pallet, folded over like that. And that sort of layer on the outside, that yellow one and that blue one, was basically protecting it from light. So if I took that liner out of this bag and laid it on here, it would cure under this light, it would cure under the sun. So as long as it's in the bag, it isn't going to cure. So we can keep that liner then for 6 months. That's what the recommended lifespan is, 6 months before you. But we have had liners up to a year. As long as you keep them in a safe place and store them correctly, you can last up to a year with them. So that takes off the risk, jumping slightly, it takes off the risk when you come to site and suddenly you find that the overpumping isn't working because this system needs the floors dry, and then you've got to stand for a day or something else, something breaks down. You're not under pressure. The old systems, which used to be cured with heat, once they were impregnated, they were going off because they were a heat reacting resin, and therefore they had to be refrigerated all the time. So you got to site, you found, my God, we can't do the job. We've got to leave the liner in the fridge before we can use it. And that was always a problem with them. So again, seamless construction, so it gives that strength. The materials are tested. A lot of materials in our industry, or the water industry, because this is where they come from, come under a term called long-term testing, which basically means 50 years. However, a lot of the work we do for Network Rail, for the Highways Authority, requires 100, even 120 years testing. So we have, this material in particular has got 120 years. This material, I think, is 100 years. There's not a lot of difference in the time, in the strengths between the 100 and 120 years. But we have all that testing here. So again, that's all independent testing. So when we do a design, we know it's got a life span of 100 years. And as I say, you can do anything sort of up to 350 meters in one go. Again, that's a big job. And simple storage on site, as you'll see, and about a 3-week lead-in. That's the only thing, got 3-week lead-in. I'm going to probably flick over this because this is just really telling you what I've told you about the different layers, the outside layer being the bag, and then you've got a wear layer and things like that. But they come to site like this. So this is a typical liner, comes from Germany, it's got all the information on here. St. Pierre, whatever that was, 24 mil thick, 16, I remember that job, yeah, 1600 diameter, 24 mil thick, South Wales under a railway. And you see on the left-hand side and the right-hand side, it basically comes like that in a box. And as long as we leave it in that box, we can leave it for 6 months. It's not going to do anything. It's not going to go off. It's as good as it was the day it was made. And again, the great advantage with this is it's fully portable. So we can go across fields. As long as we can get the box there, we've got a compressor, and we'll comment on how it's installed in a minute. We've got a curing system. But as long as we can get there, we don't need a 20-ton wagon to get there. That's one of the beauties of it. And again, non-disruptive. So a lot of the work we do, we don't need any sort of traffic management. We don't need any closures. We don't need the railway shutting in processions. We work off the side of the road, off the side of the railway, whatever we're doing, and it minimises that downtime from that point of view. Yeah. So the way of installing these liners is we CCTV, we camera it, we make sure we've got it right, the right diameters, because again, we like to do that ourselves because there's nothing worse, and we've all done it. We turn up at site because somebody tells us it's a 450 or a 500 diameter pipe, and it's not, it's a 250. And we've got a liner then that's no good to anybody. So we always like to do the investigation, check the diameters, check the lengths, make sure we've got the right sort of information before we manufacture the liner. Once we do come to site, we obviously clean the pipe, the culvert, whatever it is. We then have to overpump the floors, so the system has to be dry. It's one of the slight downfalls from it. You have to have a dry system. So one of the issues you always get is how we're going to get rid of the water, especially if you're doing, we'll stick with culverts under railways because that's a really great example. How are we going to get rid of the water? Well, we can't pump over the railway because the trains are running. The same when we're doing a culvert under a road from head wall to head wall, we can't pump over the road. So that's always the issue, whether that is putting ramps in or putting the overpumping hoses underneath the tracks, so between the sleepers is an example. Or sometimes, I have to be honest, we close the road, especially for highways, we will go in and we'll go, right, the system's very quick. We only need it closing for one day. Let's close the road on a night, and we'll put the liner in and we can pump straight over the road and there's no issues. Yes, we do build ramps and everything that goes with it, but it does need to be dry, and it's going to make a factor in a minute when I talk about other things. How's it going? There's the liner in the bag. It's the same company as this one, but he's changed his colour of his bag to silver on that. for whatever reason. The plastic here is what we call a slip plane. We put that in first just to stop the liner getting snagged on any bolts. So because this is an Amco culvert, just makes the sliding of the liner easily through. So we're winching it into place. We need to get a winch at the other end. The other end, generally we have portable winches. We can carry to places, so we can sort of minimise what we need at the other end. And the other end doesn't matter whether it's upstream or downstream. You can go either way. So whichever's got the best access to get the liner crate is the way we tend to go. So you can see there, I mean, Stroud 900. So you can see that's before we've done anything, and then that's the same picture afterwards. You can see the toilet roll effect on there, and you can see the slip plane, as we call it, inside. Just a couple more pictures paint 1,000 words and what have you. But this is what we do on a lot of jobs. So this one here, we use a different type of what we call slip plane pre-liner. This pre-liner is the size of the liner that we want to go in there. So I'm guessing on here, looking at the existing structure, it was probably, let's say 1,200 diameter. We've probably put a metre diameter liner in. So what we've done is we've got a bag, just a foil bag, and we've slipped the liner inside it. So that when we inflate this liner, as you'll see in the next couple of photographs, it will push out to the bag. It won't overinflate, and it needs something to push again, because these, to get its strength, the layers need to be pushed together, they need to be compacted together. So we have this pre-liner, so it pushes against it, compacts the layers, and we cure it, and then the annulus we grout. And we've done that purely on this, I would suspect, because of the voids, so that when we grout, we can fill all these voids in. So you can see what we do when we pull it in. We put what we call end cans, stop ends, end packers, we call them sometimes. Just basically, we open the liner out. So we open it out at each end, put these packers on, and then we inflate it with compressed air. And we're only going up to about half a bar. It will depend on the diameter, the size, the wall thickness, the amount of pressure we put in, but generally about half a bar of pressure. That inflates it out. Idea being, on a traditional liner, it goes tight against the hose pipe. Where we're doing an irregular shape, it might go tight against this pre-liner that we've put in to stop it over expanding. We then install our light train, because the resin that's in this material is light reacting. So as I said before, once it's in the bag, it's not going to go off. But we're curing it by light, so ultraviolet light. We call it a light train. It's a series of light bulbs, to want for a better expression. We install the light train. One of the great beauties of, from a contractor's point of view, which is what we are, is once the light train goes in, we have a camera on the front, and we camera the system before we cure it. So we pull the camera through to make sure we've got it inflated right or correctly, because years ago, what we used to call the boil in the bag systems, which were inverted in with hot water. And the problem always was that you would invert them in and you didn't know what you got till you cut the ends off and got the water out. And then when you cameraed it, you found you twisted it or you got it wrong. And then you were scuppered with it. It was a nightmare. I'm going back, when we used to do the old ones 20 years ago. The great thing with this is if I pull the camera through and for whatever reason we've twisted it or we've made a mess of it, you can take the air out and you can pull the line out, and you haven't damaged the asset. You've damaged your line, and that's rubbish. But at least you can then come back and go, right, we're getting a line and we'll come back and do it correctly. So it gives us a couple of safe sort of points, stop points to check. And then once we're happy, we turn the lights on and we pull the lights back at a controlled rate per minute. That's all done by a curing system. One of the early photographs you saw, a picture of a big steel box in the corner there. That's the curing system. So we tell the curing system what size lights have we got on the light train. We have different size lights. It knows anyway because of how it's all programmed. What's the diameter? What's the thickness? You'll see on one of the photographs, the boxes, and I looked at a box with a piece of paper on it, had a QR code. We scan the QR code into the machine. The machine then automatically knows it's 1,200 diameter, it's 10 mil thick, and it's got 4 times 4,000 watts. I need to cure it at a metre a minute or whatever it tells us. So it's all very controlled, and that's the other great thing about it. We know that once it's done and it's cured correctly. Generally, the rates of curing, about a metre a minute. It's a slow walk over it. So when I come back to sort of the road closure over the night, if it's a 30, 40 metre culvert, we've got it in the evening. We've got it in one shift. It's done and dusted. And then once we've got it all the way through, we trim it up at each end. Obviously, the picture on the left-hand side, we've obviously done a slightly smaller line than the hose structure for whatever reason. I do know where it was. That's up in Doncaster somewhere. Again, Network Rail. And then we pull out what we call the inner foil. So if you can imagine in its uncured state, if we didn't have this inner foil inside, once we inflate it with air, the air will just pass through the liner. So we have to have something that retains the air inside whilst we cure it. So we have this inner foil, which is see-through because the light allows it to penetrate through. And then we just unpeel that and pull that out, a bit like a bit of cling film, really, and take that out. And then your line is finished. Final survey, if we've got any laterals and it's a small diameter, then we'll go in and re-open these laterals with a robotic cutter. A larger liner, then we would go in man entry. If it was sort of 1200, 1300, 1500, we go in and cut those out. Where we've done a smaller liner, we will then grout the annulus. So you see a bit of grouting up there. The grouting is just generally a G3, general purpose, 12 Newton grout. All we're looking to do is take the loads from the soil or the structure above onto the line. The line is taking all the loads. It's just a transfer from that point of view. And again, I think the next few photographs are very much sort of before and after. So exactly the same job again. And you know, typical of what we do with the old Armco culverts, the inverts going, put a liner in it. You can see a little bit of deformation in the whole structure, which we've lined over, and that's something we would take into effect or counts when we did the structural design. I think and again, you know, we're missing bricks here. Bush farm. I think this is on here because this is probably one of the, well, it is the thickest line they've ever done in the world at 30 mil thick. The loads were very, very high on this because of the accesses to a industrial park and one thing and another. So we had a very, very thick line. But you can see here, slightly smaller, we've grouted at the back there to fill those areas where there was missing brickwork and things like that. And then we talk about big diameters, 1800 in Lisbon, in Belfast at 21 mil thick, a good thick heavy liner. We've obviously got here, we talked about the end pressures on the end caps. We've got end cans on, as I said before. We have to put stoppers in to inflate it with air. The way they generally secured is we put a ratchet strap around the liner and we clamp them in. But of course, when you've got 1800 diameter, you've got a lot of end pressure there with the air. So we had to look at temporary works and how we're going to stop those sort of blowing out, or if they did blow out, the risk of blowing out. And we do also the little weird and wonderful things. We've lined, this is Glasgow or Scotland somewhere, we've lined the culvert, but then they were widening the embankment for the road above. And so we've extended the liner out into a new head wall. And we then designed that as a buried pipeline design. It's a flexible pipe at the end of the day. So we've designed it inside the existing structure. We then extended it out 20 metres, designed that as a buried pipeline. So the contractor then came around, backfilled around this with a typical gravel bed and surround, and then built his embankment on the top of it. And these are the sort of things that we do for flow comparisons that we would supply to the client or to the EA or, you know, the local lead flood authority, to sort of prove that by reducing the diameter, we've not reduced the flow capacity of the existing asset, and then hopefully they will agree to the scheme behind it. So that's UV lining, that's cured in place lining, which again run through very, very quickly. As I said at the start, I'll make it quick for you. But it's all about looking at the job before you commit to it. Not one solution sorts everything out. We have to come and look at it. And as I say to people, we'll come and look at it. If it's not right, we'll tell you it's not right, hopefully, because there's nothing worse than going down the route of even just getting to site and then going, oh, I don't think this is the right solution for this job. Better off knowing beforehand. The other thing I want to talk about very quickly, again, is a similar sort of system, but these are pre-formed GRPs. So these come to site, a bit like, well, this is part of a piece of G-form GRP material. And the reason we use these is the bigger diameters, the bigger structures, the odd shapes where we can't put a UV liner in because A, we can't reduce it down by putting a circle in. We can't design it for a non-circular shape because it's too much of a load, and we can't make it any bit thicker than 30 mil, whereas these we can make up to, well, indefinite really, but I made them up to 70, 75 millimeters. And also where there's a flow issue. They're very good for flows. So what is it? So it's basically manufactured GRP panels. They're made in a factory, and we can make them to any shape, any orientation, as you'll see in a minute. And we tend to use them for the larger diameter structures. Okay, and I think Also gives you a little bit of options of things like mammal shelves. We can make mammal shelves into these, and you'll see a couple of pictures in a moment where we've got that. We can put fish baffles in them. We can pre-build everything into this. So they're really good for that. They're sort of good for where we can't divert the floors. So how they're made? They're made with an inner sort of surface, which is the sort of anti-corrosion barrier. We then have a middle section, which is where the strength comes from. And then the back layer, which is this sort of part here, because these are going to be slip lined into the host structure, and then the annulus is going to be grouted. So we get a good shear bond between this structure and the grout. And these are just a few pictures of different shapes in the factory. The reason for the central point where you see that grit on it is actually it's a walkway, because these are very, very slippy. So if the man entry, which generally these are, you know, when you want to go in there and inspect them in 2 years' time, there's always an issue about, oh, am I going to slip? What am I going to do? So we put an anti-slip layer. The ecologists like them because they hold the silt. Well, again, with the arguments you get, not the arguments, but one of the problems you have is that they're too smooth. So, of course, the silt comes straight out, which the client likes because they don't have to clean them. But the ecologists don't like because you're losing the bug life and the silts that are in there. Put the anti-slip on there. It gives the advantage of holding the silts, and therefore they quite like that. So you're arguing between two different people, and again, different sizes and shapes that we do, and things like manholes where we've gone through a particular culvert and then they want to put a manhole on top of it. We can do that in preformed GRPs, and as I say, these come manufactured overseas, so we have to ship them. Generally, they're shipped in 20-foot containers. We sometimes do them in multi-pieces, top and a bottom, or 3 pieces. And this is because we've got difficult access on site, or it's more cost effective to get them into a container. If you've got a 2.4 diameter pipe, the circle, let's say, for argument's sake, you're only going to get 1 in a container, or however many. If you break them in half, you can get 20 meters in that container, and it then reduces the shipping cost. And then we just assemble them on site. We've just done a recent one, which I know is not in this thing, again in Belfast, where it was, I think, 3.5 meters tall by 2 meters wide. It was a massive unit. So we got that in a top and bottom unit. So we could build it on site just to save on the shipping, and it made it a lot easier and a lot quicker from that point of view. And they're joined by a fully structural adhesive, which in effect is, you know, a bit like welding, is stronger than the host material. So there's no issue from a design point of view on that. And I think that's an example. You see, you know, you can get whatever 6 in that one, or you can get whatever different, you can get so many more. That's it, 6, 10 and 16 in the same container. So it shaves on the shipping costs because we are shipping these from a distance. And one of these things is about the design and about the measurements. So again, we need to measure this, because I don't want anybody else measuring it, because when it's the wrong size, we can't do anything with them. And I have to say, but we've only ever had it once, and it was my fault because I measured it, and we measured it wrong. And now I've still got these liners 7 years later, and they're still in our yard. And every job I ever get, I'm looking for the bloody same. And I know full well we're going to throw them away, and then about a month later we'll get a job that'll fit them. So we like to measure them, and we measure them in 2 ways, and I think we're going to come up with that in a minute. So these are just different sort of things. This is put up. There's Coventry. That I was going to say it's Warwickshire, but it's Coventry. And again, you see here, this is North Yorkshire. Little sort of dry weather flow channel in it. We've slipped those in, and we're now grouting the annulus around the outside of it. And we're not really pumping under pressure. We're just filling the voids, in essence. Again, Norbury's culvert there, up in thing. How they manufactured by hand, because everyone we tend to use is bespoke. Very rare that we'll use a circular 1500 diameter pipe, because we'll tend to use the UV cured. It's quicker. This is a little bit slower installation. So they're all manufactured by hand in a factory, where again extensive testing is done, and everything is sampled and tested. So we have a lot of this 100-year design life that we can look at. And this is where they come into their own. This is a job for Warsaw, and we had 2 twin culverts. You can see all the bends, but what we can do is we actually make a little bit of a jigsaw puzzle. So the guys on site know they all go together, and this is how they all go together. And we've established that using a point cloud survey. Similar thing here. This is a job for Beckles, It's put the EA, but it actually wasn't. It was for Network Rail. And you can see the weird and wonderful bends. It was only 900 diameter. But the reason we did this was those were putting in the wet. We couldn't overpump the floors because it went under a road and then it went under the railway by the level crossing. And it was just a nightmare to overpump, to actually go over the tracks, then go over the road by the level crossing. So we installed them in the wet, and there's some better pictures coming up. Now, actually, this is how we do this, is it? Let me send, I've got to press play. How do I press play on this, Jason? Oh, yeah, I do. So this gives you an example of an arch with a flat bottom with a GRP. This had numerous bends, as you'll see on this video. It'll go round. These are the lateral connections that we've re-pieced in. And this was for Suffolk highways under the road there. And it went round. Hopefully a little bit quicker. The lateral coming in. And I think the reason this video is on here is the fact that it just shows a good example of how we can accommodate bends in it. But also, we had an issue here with the flooding models that were done. We needed to keep the existing capacity as it was. However, the culvert had been extended at some point in, I think there were 1,500 diameter concrete pipes, the last sort of 10 metres. But we had to keep this capacity for storage. So you can see this last unit is a transition piece that we've actually made. Then we've come down into standard circles and we've leave line that. See, this gives you this flexibility to do any sort of shape, any orientation, and change it along its route. And now do go along this one. Oh, there we are. As I said, the current site, it's not one of ours, isn't this? I'd like to say. Could stack them like that now. But they come stacked on site. They then drop down into the culvert and we're literally pushing them in. So this is where we need the annulus. And we have different lengths of units. So a lot of the time we might have them 2.4 long. That's the longest we can make them with a joint. We might have them 600. We might have them 1.2. Again, it's the ease of access, lifting, carrying, manoeuvring these things into place. So just some big diameter, sort of 4.8 diameter liners that have been done there. And also this ability to have multi-section. So, and I know this is, I think, a Thames Water job many years ago. We made it up in panels. So we actually installed it inside. So we get down through a manhole lid. So we go down through a 600 by 600 cover, save digging a big shaft. But these next photographs are a good typical example. This is up at RAF Valley in North Wales. Typical twin culvert going under the railway lines just by the RAF base. And you can see there the shape that we've got. The guys are pushing them in. So they'll bring them in. They're jointed with a spigot and socket joint. And we have different ways of moving them, by hand, by a little trolley, depending on the weight, to push them through. And then once they're all in, we then start the grouting. So again, all of that has been done during normal working hours with no disruption, no downtime. And this sort of shows the typical sort of grouting installation that we have. So we grout it in stages. We're not looking to put it under pressure. We're just looking to fill it. So it's a high flow, general purpose grout that we tend to use cementitious material. And again, we can do all sorts of weird and wonderful sizes. This is Ulverston in the Lake District, the big flood Zenith scheme. And these next two slides, I want to show you about the overpumping. What we can do with the overpump, this is down in Surrey, we can put them in the wet. So you see the guys on the left-hand photograph with the waders on. You see them in the middle that they're now installed. And what we would do is we would leave them maybe 6 or 7 inches apart. We would just get them into place. We'd then set up overpumping and pump through the middle, and then we do the final jointing. So we don't have to overpump there, or we don't have to get the pumps over the railway or over the highway. It just saves on that flow management. That just makes things a little bit easier. And then, oh, we've got another video. I showed a picture of a job in Warsaw where we had a little jigsaw puzzle. This is how we came up with the jigsaw puzzle. So here we've done a point cloud survey. So you can see on this that how sort of detailed they can get us the information. We don't do them ourselves, unfortunately. We have a surveying partner who will come in and do this sort of thing. So it was a twin box that ran under a road that we're actually upgrading. They wanted to upgrade the road because it was turning into a bus turning area. and the existing precast planks didn't feel that they had the strength. So what we did here, we surveyed both tunnels, and that gave us the orientation, the layout of the units. You can see how detailed these sort of surveys give us, and the information they give us. And again, we use GRP here because over pumping would have been a no-no, even though there isn't much flow in it. But then you'll see in a minute the join on that type of thing. That's just going under there. I think it pans round, but I think you get the impression, the detail on there. And that is the finished article. On the right hand side, that's just done, and there's the installation going ahead. We're building some temporary sort of stop ends to do a bit of grouting before we continue with the next section. And we talk about point cloud surveys, but I have to be honest, we do wonderful point cloud surveys that you've just seen, but I'd much rather go in with a piece of wood and flipping measurement. You know what I mean? You know, at least then you know you're right at the end of the day. You know, there's nothing worse than, like I say, turning up and it's all my fault. And again, these are just sort of some pictures here of Ulverston, the EA. We did some big screens up there under the village where we use the preformed GRPs on that section, and things like that. So again, finished the article, piecing in, see the terrible state of the existing. And then there's sort of stuff a little bit about finishing off. You know, we joined the units. The reason I think this is in here is because of the mammal shelf. We built a mammal shelf into the GRP for our little furry friends. And again, that's the same job. And there's two questions. There's two things that people can ask about this. One, where's the type 1? Looks like type 1 in, back in. That again is for the bug's life, for the ecologist. Why is there so much grout over the top of it? Why didn't we make it bigger? Well, because these are so smooth, there was a concern about flooding downstream. And the EA were very insistent about, right, we only want it this big because we don't want too much water downstream, and hence why we've got that sort of quite a lot of grout over the top, which is not something I'd like to see, to be honest with you. Essex, we actually put a mammal shelf in this. We actually put it in retrospectively because if we'd have taken that much out of it by doing it as a GRP as the previous one, we'd have lost too much capacity in the actual structure. We needed to get as much capacity through there as possible back when we were starting to reduce it, and that was one of the restrictions. And again, Leicestershire, we've now put back boxes in to look after those people, keep them happy. But again, we can do vertical shafts. So this is a job for Welsh Water we did last year, where I think it was a reservoir, and we built them up about 2.4 diameter, strengthened the shaft because it was slightly moving, and there was increased load and water pressure. We built this up for those guys. So in a way, again, it's just another tool to look at a job and say, well, actually, you know, it should be UV lining, but actually it might be better doing it with a GRP. So we just look at different options to do that. And I stress all the time, it's all about coming and have a look at it, see if it's right. Doesn't cost anything. We don't wear it. We'd rather come and see it and whatever, and do that and stuff. So things the sort of people we work for, like yourselves, anybody with a culvert really, or anybody with a pipe and things like that. And I think that is it.
Yeah.
To be honest with you. So if you've got any questions, fire away. If you don't, brilliant, you can go. And I've done just in my time slot, I think.
Yeah, brilliant.
Just about the UV. What's the minimum diameter you want?
When it comes here, if you asked me that 10 years ago, I would say 150. Okay. The problem with UV is the curing systems for UV really struggle in 150. They are tight. You can do them, but the pipe has got to be absolutely perfect. If there's a slight step joint in the existing, the light train won't go through. So I'm always reticent to saying, the smallest I do is 225 with UV. Now, over the last few years, they've developed what's an LED system, what some people call blue light. And that's an LED curing system. And the light train for that is much, much smaller. And that's brilliant for 100s, 150s, 225s. So in a way, if I was doing something small, I would go down an LED curing system, which is very, very similar. to the UV. It's just a different curing method, really. It's a similar sort of material and things like that. It's not as strong, but it'll give you what you need on a 150 because you don't need a thick wall thickness on a 150. You just haven't got loads on it. So you can go down as literally that small nowadays. Yeah.
Any more questions? So, the speakers from today are still here, so we'll be here till 1:30 if you want to go out and have a coffee. If anyone wants parking pass, let me know. If anyone wants a CPD certificate, I can give you one of those as well if you want one. Some people still ask for them. So apart from that, thank you very much.
Yeah, thank you all for coming. Thank you to teaching them out your day.
They can email them.
Oh, okay.
Yeah. But like I say, I'm sure it's the same with Minova and Mainmark. If you ever think about anything, ask.
Yeah.
Because I think we'd rather say to you, this is right, this is not right, before you get too far down the line and it isn't right. That's all I was saying. It doesn't cost anything. We're all happy to help you now. It's the main thing.
Yeah, brilliant. Thank you very much.
Guys.